See what happens.
Am I supposed to start now anytime or?
Hi, Thomas. Now I'm just going to do an introduction. We're just waiting for a few more people to join.
I just want to make sure that I wait for your sign too.
Yeah, not a problem. I'll let you know.
Excellent.
Good morning to those that are joining the Maritime Aviation webinar. We're just waiting for a couple of more minutes, just as more people are joining, and then we'll be underway. Okay, so good morning to everyone, and welcome to this Maritime Aviation webinar that's really going to focus today on the transition to fluorine-free foams. The superyacht industry currently faces significant challenges with fire safety driven by the evolution of products and equipment and new regulations designed to mitigate risk to those on board, along with the vessels and other high-value assets such as helicopters. This morning we are focusing on the firefighting foam concentrates, which, as you know, have been a part of the furniture at sea for decades. However, like many items that we may come into contact with on a day-to-day basis in the workplace and at home, science can sometimes unearth the unknown, identifying risks to our health and the environment. Unfortunately, this is a situation that the maritime and other industries are currently facing with fluorinated foams, some of which have been identified as hazardous and their use now being reviewed. Our panelists will elaborate further during the course of this webinar, which I hope you will enjoy. Just a little bit about Maritime Aviation for those of you who are not familiar with us. We're seen as the global leader in helicopter operations on super yachts and cruise ships. We are the only industry organisation that provides services as an aviation inspection body, heliport design consultants, heliport crew training and equipment supply through our heliport supplies outlet. We're currently engaged with aviation capable vessels ranging from 60 metres to 350 metres in length, and are privileged to be close associates of other renowned industry businesses within our sector, some of whom are at this webinar today. So firstly, to introduce myself, I'm Richard Selby and I'm hosting and facilitating the webinar today. And prior to my 13 years in the superyacht industry, I come with decades of experience spanning the Royal Navy aviation, in the air, on the ground and at sea, defence, civil aviation and local authority fire and rescue, covering risks ashore and at sea. And I've also spent time involved with maritime search and rescue, and I'm currently a commissioner and board member of the Port of Poole and Poole Harbour. Joining us today is Dr. Thomas Leonhardt, who's the chairman of Eurofuel Extinguishing Agents Committee and a product manager at Dr. Stamer, and he will present the current position of the European Chemicals Agency and the International Maritime Organization, and why the superyacht industry should move to foam concentrate transitions now. We also have Matt Calverley, who's the Senior Business Development Manager at ProDecon, and we'll talk about the need to decontaminate your foam equipment on board and how to instigate it. My apologies. And last but not least, Jan Nappert is the International Sales Director at Dr. Stoma, who are a leading manufacturer of firefighting foam concentrates. Jan will present the latest on foam concentrate development and how they're performance-based for your safety and protection. In terms of housekeeping, delegates will be muted with their video turned off throughout the webinar. In terms of question and answers, you can enter your question in the question box at any time, and at the end of the presentations, we will go through questions asking the most appropriate panelists to respond. So without further ado, I'd like to introduce Thomas, who's going to start with his presentation. Thomas, over to you. You're muted, Thomas, I'm afraid.
Oh yeah, this is thank you. Yeah, thank you, Richard, for the kind introduction and also for having me here for presentation, and welcome to everybody out there listening to the presentation today. I'm attempting to share my screen, hoping it'll work well. You should now see my screen. Probably a quick word to myself. As Richard said, I'm currently working for Dr. Stoma as the General Product Manager, but a part of that, I also have a couple of other roles, one of which is I'm the chairman, the founder and chairman of the section Firefighting Agents within Eurofir, which is again the overarching European organization of the fire protection industry. And we have been involved very deeply with PFAS legislation in the past couple of years. So we participated also in the meetings of RAC and SEAC, the two technical committees of the European Chemical Agency, which are more or less developing the underlying principles of the legislation that we have been seeing and will be seeing in the future. Okay. So today we're going to talk about a little bit what is the background of all these changes, of this major change, as what we're seeing today, the transition away from AFFF foams is probably the second biggest impact on foam technology ever, the first to be the invention of AFFF foams. And now we're going back to square one with fluorine-free foams, and it seems that we have to relearn foams from the scratch to some extent. So I will talk a little bit about the legal background of PFAS restrictions, what is in place today, what's going to come. Of course, IMO has also addressed some of the issues arising from that. One is particular the Stockholm Convention, which is a global agreement impacting the foam business. And then we're talking a little bit about what needs to be done in order to transition away from AFFF and why it is important to consider a change as soon as possible. Well, when we talk about fluorochemicals, the one thing that has been very obvious in the past couple of years is that legislators globally are restricting the use of so-called fluorochemicals, which is organic chemicals consisting of fluorine. And these chemicals have one key property in common. They are extremely stable to other chemicals, to physical and chemical impact, which is why they have been invented and why they are used very widely in the technology and the technical applications in the last couple of decades. And this is, of course, also a concern, because if they are persistent, they build up in the environment and they will not degrade, they will not go away. So even if they have very, very little toxicological impact or toxicological effects on different types of life, over the course of time, by building up the concentration in the environment, legislators are concerned this impact is going to grow with the concentration. So as I just said, the UN Stockholm Convention is an international global treaty signed in Stockholm, which is where it got the name from. And the Stockholm Convention deals with so-called persistent organic pollutants, which are chemicals that are non-degrading easily. They are persistent, they are toxic, and they build up in the environment. And that is why the global community has come to the conclusion to restrict or ban those chemicals. And a couple of those fluorochemicals that are used in firefighting foams, like PFOS, PFOA, and just recently also PFHXS, have entered onto the list, have been adopted onto the list. And now all the signees of the Stockholm Conventions are obliged to turn that into their national legislation to actually ban these chemicals. You will see those acronyms a number of times. I'll explain them as they come along. The European Union has prepared a complete phase out of any fluorochemicals, not just in firefighting foams, but also in any other uses. There's two big blocks of legislation just in work in progress as we speak. China is preparing additional restrictions on PFAS, which is an acronym that stands for perfluorinated alkyl substances. That's the entirety of all fluoroorganic compounds. The US have very tight restrictions in some states, and more are to come, and it's even been talked about a central law. Australia has already restrictions in place, and it's tightening those restrictions. Canada, New Zealand, and so on and so on. You see that more and more international legislations are tightening the screws on these chemicals. So it is very likely, if not certain, that AFFF and the likes, so foams, firefighting foams with fluorochemicals in them, will not be available for anymore in the future. For sure, they won't be available in the EU. Well, the landscape of European legislation on perfluoroalkyl substances is split into, at this point in time, over a couple of different chemicals, such as PFOS, which is the acronym for perfluorooctyl sulfonate, which is a surfactant type molecule that has widely been used in the old C8 technology firefighting foams. These were the foams of 3M. And PFOA, which is the perfluorooctyl acid, again, a chemical that has been used in the old technology. And then we have the so-called C9 to C14 PFAS. We talk about perfluorohexanoic acid and perfluorohexanoic sulfonate. So basically, these two C8 compounds that you see up here, I hope you can see my mouse pointer, are representatives of what we call the C8 technology. This is more or less legacy foams. They have been transitioned away from in the beginning 2008 and 2010. So most of these chemicals already disappeared from the market. If you buy a new AFFF foam, you won't get any of these C8 technology stuff anymore. C9 and C14 is just another chain length. Instead of 8 carbons, you now have 9 to 14 carbons. These chemicals have always been only around as trace contaminants, so they are also phased out together with the C8 technology. And the change from C8 to C6 technology wasn't very difficult, because C6 technology basically was exactly the same type of foam. It was just a different ingredient. But all the other properties of the foam and the foam concentrate were almost the same, which is why the transition away from C8 to C6 was not so much of a problem. You see that now there is 2 representatives of the C6 technologies, technology which are considered to be restricted. Perfluorohexanoic acid would be basically putting an end to AFFF foams as we know them today. And then there is another, as I said, big piece of legislation in Europe, which is the restriction or the ban of any fluorochemicals, no matter what. It's split in two parts. The so-called PFAS restriction is F stands for firefighting foams, focuses on firefighting foams only, and it's expected to enter into force in this year. We don't know if this is going to happen yet because the ball is at the court of the European Commission. All the legislative steps and bits and pieces before were phased out, and now it's the Commission to basically decide on the final legal text. And then there is the UPFAS, which just has started. U stands for Universal PFAS, which covers use of fluorochemicals in any other applications, starting from stain-proof suits to Teflon coatings and Teflon sealings. Now, the so-called PFAS restriction, as I said, the RAC&SEAC work is completed. So the two technical committees which decide on risk assessment and socio-economic assessment have completed their work. The participation of the public has been timed out. So now the ball is with the EU Commission to set the stage. What has been discussed in the last draft, and this is why everything is grayed out, we don't know for sure if it's going to come this way, is a couple of derogations. So basically, it will not be possible to place AFFF foams on the market 6 months after entering into force of the restriction. And there is no manufacturing until 10 years after entering into force of the restriction. And then there's a couple of derogation for uses. Training, testing, and municipal fire brigades are facing a very short-term derogation of only 18 months after entering into force. They will not be allowed to use fluorinated foams anymore. And then probably the part that is of interest for you guys most is civilian ships. 36 months after entering into force, there is no more permission for use of AFFF foams or the likes on civilian ships. So you have to transition away within 36 months, which is, of course, very ambitious. Civilian aviation is 60 months, and the portable firefighting extinguishers as well. And also anything but what is mentioned on this table. The only longer derogation is on Seveso 3 industries, which have a maximum of 120 months, so basically 10 years to transition away. So as I said, the important thing is that at this point in time for civilian ships, the last proposal only foresees 36 months, which is basically 3 years for a transition. Well, what does IMO do about it? In 2022, both SSC and MSC adopted a decision to recommend the banning of PFOS, which is basically following the adoption of PFOS onto the list of persistent organic pollutants of the Treaty of Stockholm. So far, it is just a recommendation to ban PFOS. However, in recent IMO publications, you find a text passage which says or recommends to prepare for 2026 a foam firefighting ban, which is obviously not quite correct because it's not a ban of firefighting foams. It is only a ban of certain chemicals in firefighting foams. So be cautious about publications and statements like that. The tanker operator says in SOLAS Chapter 2 and HSC codes will be amended by a ban of any firefighting foam agent containing PFOS. And again, just as a reminder to my introduction, PFOS has already been banned from the firefighting foam technology starting in 2008. And in 2010, the legal limit was again lowered. So I think PFOS is not an issue today anymore. If you buy foams in a big chemical legislation such as the US and Europe, etc., you won't find any PFOS containing foams. However, this ban applies to fixed and mobile systems. Existing systems need to remove PFOS and dispose of ashore. Any of the above must be completed no later than January 1st, 2026, and reference is made to the UN Stockholm Convention. So far, I have not been able to find any legal limits that are associated with it. So how much trace amounts of PFOS would be accepted, which is a little bit difficult or dangerous if you're caught between an excessive cleaning to get as close as possible to a zero and to do no cleaning at all. And somewhere in between the truth is going to be. So far, we have not seen any legal limits, but it would be important, of course, to agree with permitting authorities to understand to what level of purity have you to clean your installations. Well, how big is the risk actually? As I said, PFOS is already restricted in many legislations since several years. PFOA is mostly phased out as well since 2020. And consequently, the fluorosurfactant manufacturing industry has almost completely moved away from the so-called C8 technologies. And foam agents that are sourced in regions with restrictions on C8 and are younger than 2020 are not affected by this. High expansion or inside air foam concentrates are also likely not affected because they are fluorine-free foams per se. Well, we've been talking about the Stockholm Convention, the POP list, a couple of times in the meantime. And it's as I said, a UN treaty that regulates persistent organic pollutants, which is chemicals that do not disappear easily in the environment. Once you brought them into the environment, they are just there. And for some of them, the degradation time or half-life in the environment is hundreds of thousands of years even. So ashore is PFOS banned already in many legislations for years, and the UN Stockholm Convention is moving on. So one of the first was PFOS, as you see in this publication, and then there's another couple of perfluorochemicals that they have in the pipeline for an adoption onto the POP list, which would lead then to similar restrictions compared to PFOS. So the next one is PFOA that has already been adopted. PFHXS, which is the perfluorohexanoid sulfonate, has already been adopted. These two chemicals are both chemicals which, as a chemical, are not present in firefighting foams, but only as trace amounts. And then we have the C9 to C11 PFAS. Also, those are only available in trace amounts. So coming back to IMO's take on PFAS, on the totality of PFAS, the IMO is also looking at extending the ban to other fluorinated substances, so not just PFAS. That is already pointing towards the future and what's going to come next. A new section, fire extinguishing media restrictions, will be added to the SOLAS and HSC codes to allow for an easier adoption of future prohibitions or limitations. And what does that imply? First and foremost, the supply of fluorinated foam agents may dry up as the applications for fluorochemicals will fade. Replacing PFOS-contaminated foam agents by other AFFF may turn out to be a regrettable investment. You may see that if you replace C8-based foam now by C6-based foam, that the new foam is not going to see its natural lifespan, the end of its natural lifespan, but will have to be phased out again in between. System adjustments should consider to use fluorine-free foams if you do the change today. So anytime you put the vessels in the dry dock and you rework and clean up all the installations, the firefighting installations, to prepare them for new foam, it is well recommended to consider doing that for the use of fluorine-free foams, because that is what is going to come for sure. You might be facing a shortage of resources alongside the transition, which is a supply of all different types of materials for reconstruction, for whatever, disposal resources, approval resources, testing resources, all of that is going to tighten up in the next couple of years as the entire market is moving away from fluorochemicals. This is an extract of the most recent proposal of the ban for PFAS in firefighting foams, and it clearly says 3 years after entry into force for civilian ships, including tankers, ferries, tugboats, and other commercial vessels. It's not talking about private-owned vessels. However, what we have not seen yet is a clear instruction or a clear understanding of how the European harbors will treat boats that have fluorinated foams on board in the future. Well, when we talk about a transition project, some of you might have been going through this C8, C6 exchange, and they found it to be very easy. You take out the old juice and you just wash the containers. You had the old juice in the storage containers and you backfill them with new juice. When we talk about fluorine-free foams, this is very likely not the case like that, simply because fluorine-free firefighting foam agents are very much different compared to AFFF. They have a higher level of interaction with liquid fuels. We're not concerned about Class A fuels or Class A fires. So any fires of plastics, of tires, of other Class A solid materials is not so much a concern. These are fires that fluorine-free foams can evenly well handle, or even better handle compared to AFFF. But liquid fires is the big thing. We have a much higher level of dependency on a functional foam quality, because we're now no longer having the chemical support of the fluorochemicals, but we need a good quality foam blanket to be actually able and physically extinguish the fire. The effectiveness of a firefighting system is much more depending on an effective foam application compared to AFFF. AFFF are very forgiving, and even the foam application that was almost not impacting the fire performance, or just slightly impacting the fire performance. Now this changes, and the way of application of the foam blanket has a major impact on the effectiveness of the approach. They are also responsive to water qualities, not just fresh and seawater, but also to, say, water qualities in between, things like industrial water, which can contain, to some extent, corrosion inhibitors or biocides, etc. And these chemicals do have an impact on the foam quality, and with impacting the foam quality, they of course also impact the fire performance of a foam. Stability of concentrates is an issue. Viscosity very clearly is an issue. All of the high-performing fluorine-free foams you find on the market today are high viscous products. And there's probably even more. So coming back to the transition project, yes, you have to take out the AFFF, but then we get into the details of the minutiae. We have a lot of cleaning efforts to be able and meet the legal requirements. You have to consider selecting a new foam, which needs to be adjusted to what you have in means of hardware, what you have in means of fire risk, say fuels, etc., etc. Maybe you have to do some changes to the system. You have to do a relisting of the system, so reapprove the system or get a new permit, operating permit, etc., etc. And all that together is consuming quite a lot of time, in particular, since many others are doing the same. So time is very much an issue when you're transitioning away from AFFF to fluorine-free foams. Well, we're often asked, is it then important to start now? We haven't seen the law yet. We don't know when it's going to enter into force, etc. But consider the following: transition does require a thorough review of the fire protection concept, and depending on this, on the complexity and the size of the concept, that may have a big impact. It is, of course, a lot of difference if we're talking about a 50-meter yacht or a 300-meter container vessel or a chemical tanker or whatever. So there's quite some differences. However, the more complex this whole thing gets, the more difficult the whole thing becomes also. Defining and developing the necessary changes to the concept to keep it working, to keep it in shape, means to plan, to test, probably to apply for approvals, to do function test, etc., etc. So all of that has to be operated in the background and prepared for the meeting. Then we're talking about selecting a new foam. As I said earlier, the new fluorine-free foams are more selective or more affected by the interaction with the fuel. That means you need to know, you need to very clearly understand your fuels, and you need to select the foam that fits best to all of your fuels. And you might even have to consider to restrict fuels on certain boats, depending on the firefighting system they have on board. Constructing the new system, changing to the existing one. We talked about the viscosity. If you imagine you change from Coca-Cola to ketchup, you have a very clear understanding of what changes you need to do to your system to still make it work. And that's what we're talking about. And then, of course, disposal of the old AFFF foam. There's capacity constraints we are already seeing. So high temperature incineration plants are already running full, and the prices for disposal have ramped up from approximately 300 euros per ton to now over 1,000 euros per ton. So you see already what's going on there. So long story short, it is time to move now. Well, how to prepare? Well, it is, of course, recommended to start at least with the planning for the transition right away, and this way to maintain control over the process. The restrictions on fluorochemicals will come. There's no question about it. The only thing that is in question is the extent of restriction, the extent of derogation, and the exact point in time when they enter into force, but they will come. So it would be well recommended to start with analyzing your foam stock for the level of PFAS contamination. Maybe if you do not have a PFOS contaminated foam at this point in time, you may not be forced to immediately act to meet the 2026 deadline, but you will certainly have a little bit more time to plan the transition away from fluorine-containing foams. It is important to analyze the typical or planned payload for chemical hazards to be addressed on board, because you need to select a fluorine-free firefighting foam that fits best to this type of fuels. Then, of course, you have to select the foam concentrate, and this may include that you have to do some pre-testing depending on what chemicals are transported on board. You may have to run some additional tests because we as manufacturer do a lot of testing of our firefighting foams, but there's no way we can test our firefighting foams on the over 60,000 commercial chemicals that are known in the marketplace. There might be a need to change or alter or modify the onboard fire extinguishing system. That typically affects the proportioning system, the piping to the supply stations, etc., etc. And that needs to be looked at, and it may, if in worst case, require some dry dock time to get this fixed. Those dry dock stays, of course, need also to be planned to be able to execute the upgrades. And finally, you may need to talk to insurance companies, flags, and also authorities to get your boat relisted and reapproved for operation. And then, of course, one little piece is often forgotten, which is training of the crew on using this new type of foam. It is not you're replacing A by B and everything else stays the same. Using AFFF does require some more deeper understanding of how foam works to enable the crew on board to effectively operate the firefighting system and the firefighting technology installed. So training, don't underestimate the need for training of crews. Well, as far as the final countdown is concerned, once you've planned all your transition needs, you've agreed with all affected parties, with the owner, the flag, insurance companies, etc., then you have done your fuel check. You know exactly what the chemicals are that you are dealing with. You have done a hardware check, so you know that the hardware you have on board is capable to produce functioning foam, an effective foam from the foam agent that you selected. You have done an application check, so how do I best apply the foam? What kind of applicators do I use, etc.? And you have trained your crew to effectively use it. And then, of course, you have selected a foam agent that fits best to your needs, and you have the new foam on site to be filled in. And with all of that, you are ready to take off. And with that, you made it. Happy to take your questions, should you have some.
Just bear with me. Okay, so thank you, Dr. Leonhardt, for that great enlightenment about this challenge with fluorinated foams. And I think, you know, I thought I knew a fair bit, but there's been some interesting eye-openers there without a shadow of a doubt. One thing that is for sure that is emerging is the testing of finished foam, which I'll just touch on at the end. But nevertheless, as part of this process, and what is important, of course, is the simple fact that we need to be able to decontaminate our systems and prepare them for the transition. And therefore, I'm privileged that today we've got Matt Calverley from Process Decontamination, who's going to talk about that with us. Just bear with me while I hand over. All over to you, Matt.
Brilliant. It's not letting me share, Richard. Oh, there we go. Okay, brilliant. Okay, thank you, Thomas. Thank you, Richard. So my name's Matt Calverley. I'm from a company called Process Decontamination Systems. We're known in the industry as Prodicon. We are a UK-based organisation working internationally, and we are the market leader in the provision of decontamination services. Our core business, if you'd like, is hydrocarbons. We work with a lot of industrial customers in hydrocarbon decontamination. And around 3 years ago, we moved into the PFAS market with our consultant partner, Tetra Tech, who specialise in the subject of PFAS. When we talk about decontamination, the way that we apply our chemistry is through a closed loop system, if you'd like. So we have a circulation skid, which is connected to pumps, and we circulate chemistry through a process unit or a foam suppression tank, and we would circulate that over a number of hours using different methods of application to ensure that the hazard is removed as effectively as possible. And we've got a proven track record in decontaminated over thousands of circuits. We've done approximately 150 to 200 systems now in the PFAS world. So we operate globally. So we're based in the UK and Europe, but we have a number of partners that allows us to operate much further afield, over in South America, the Middle East, and actually more recently Southeast Asia, where we've recently signed a partnership. Our equipment is designed to travel, and I can show you some images of that shortly, but we take the solution to the customer, if you'd like. So all of our equipment is contained in 20 or 40 foot containers. So when we're moving overseas, that equipment is shipped to the customer, and the solution is delivered where the customer is based. I mentioned previously our partner Tetra Tech. They are an American global consultant. They have much further reach in terms of operational footprint. So where you can see all of those different various coloured dots, if you'd like, are areas we are able to support with PFAS decontamination services. So we'll just touch on this before I go into safety, into the decontamination aspect. There's a number of images there. This was from the Amsterdam Harbour Authority, where we recently decontaminated a number of their boats. The top left image, that's the equipment being dropped off, if you'd like. So that contains all of our equipment, the chemical, the pumps, the circulation units, all within that unit. And it's quite a neat system, and that is it's effectively the same setup for our guys. When we travel over there, they can open up the container, they're used to the equipment that's in there. Obviously, with the industry that we work in, safety is really important, as is quality and environment. We've got an exemplary safety record. We're very much left to our own devices on our customers' sites now. We don't need to be managed. They trust us to operate on their sites. We've got all of the established business management systems and the procedures developed for PFAS decontamination, and we're also ISO accredited for chemical cleaning, which is quite unique, especially in the PFAS decontamination industry, and that's accredited by 9000, 14000 and 45001. So if we move on more to the subject of PFAS decontamination. So I mentioned our partners, Tetra Tech. So just shy of 3 years ago, we entered an exclusive arrangement with Tetra Tech. At Tetra Tech, they developed the chemistry, the PFAS scrub chemical agent that we utilize to remove PFAS from the tank or system walls. That chemistry was developed at the US Department of Defense. And Tetra Tech wanted to look for a partner who had experience in decontamination. No system is the same. So they were looking for someone who was an expert in decontamination, who could partner with experts in PFAS. So together we developed the relationship. The way that the partnership works is Tetra Tech supply the chemistry, and Prodicon manage the customer and all of the in-field decontamination. Once we've done the analytics on the analytics to verify the success of the decontamination, those samples and swabs, they are sent to Tetra Tech, who then issue those to an accredited lab where the PFAS, PFOA or PFOS even is analysed to understand the success of the decon. Once we get the data from the laboratories, which I will talk about in more detail shortly, Tetra Tech then develop an independent report, which is passed on to the customer to inform them of the success of decontamination. So together we've got a combination of experience, and we like to think we have a market-leading and best practice solution for industry to transition from foam successfully. So why do we decontaminate? So PFAS, the reason it's there, it's a waterproof, it's an oil-resistant chemical, and that's the reason why it's very good at suppressing fires. PFAS, there is an image to the right. So the way that the PFAS forms is it forms bilateral layers on the inside of the tank. So the foam that contains the PFAS, over time, the PFAS forms on the wall of the tank. And that forms in lots and lots of bilateral layers. And over time, those layers are very difficult to remove. You know, an analogy of that is if you're you know, redecorating a house, if you'd like, and you've got layers and layers of wallpaper, you need to strip those layers off. And that's the way that PFAS works, in a way, that you need to strip them off. Through the decontamination work that we've been doing, you know, we've done a lot of decontamination of systems that have had C8, which is mainly the driver in the legislation at the moment, but we have done a lot of systems that have had C6 foam. The problem that the industry has is if you don't effectively remove this PFAS, then the PFAS will rebound into your new foam. There is no legislation that says how clean a tank needs to be, but the legislation is based on the foam. And if you don't effectively clean the tank, what will happen is that the PFAS will rebound into your new foam over time. Then you'll have regret spend in the future because your foam may be outside of the legislative requirements. So I mentioned that we have done some C6 systems, and that's partly because we've been analysing foam of customers to test their foam to understand what the PFAS levels are within that foam. And they in the past have done ineffective cleaning, if you like. They've not done a proper decontamination, and we've seen elevated levels of PFAS in C6 foams where they have not carried out a successful decontamination. Evidence of this is further. There was a project that was carried out at Qantas in Australia. They transitioned to a fluorine-free foam. There was an incident where the mechanical contractor opened up the foam dispersed all into the ground. The consultants came along, they analysed the ground levels, and they found significant levels of PFAS within the ground. Now, that was quite strange because they had a fluorine-free foam, and the levels were 1,600 times than the current EU regulations suggested by ACA. What came to happen of that is that's where they really started to understand, well, hey, you know, this was a fluorine-free foam, where's the PFAS come from? And that's where they started to understand how PFAS started to layer on these systems, and that there needed to be an effective means to remove that PFAS to prevent that from rebounding into your normal foams. This is where the PFAS scrub chemical comes into play. It's designed to dissolve and absorb and remove layers of self-assembled PFAS. So when we're talking about decontamination, experience does really count. You know, we've got a huge amount of experience, not just in the PFAS world, but in dealing with process equipment across some of our customers' sites, predominantly in the oil and gas and petrochemical industry. Now, every fire system is unique, and you know, we've done systems from 100 litres up to in fire engines up to 42,000 litre tanks. We are looking at even bigger than that at the moment, but you know, without doubt, there is always in-field challenges. You know, something's been missed, each system is different, and you need to overcome that. And that's really where the experience comes in. If I just look at the two images to the right there, these are two boats. And one of them, well, the top image is in Hull, and that's where we've got access to the tank. So we're able to decontaminate or circulate our chemistry into the top of the tank through the manway, where we fabricated a spray head mechanism, if you like, that sprays the chemistry onto the tank wall, avoids us having to liquid fill the tank, which can be costly because you have to add a lot more chemical, and you would then produce a lot more waste as well. Liquid fill is not ideal, so we always look to a spray head mechanism. The second image at the bottom there is where we can't access the tank. The tank is inaccessible. So we've had to liquid fill, and we've had to go through the foam loading system on the deck of the boat. And that was the only solution that we could come up with, just to access issues. But still, once the decon was complete, we carried out all of the analysis, and both solutions was successful. So we were often enough, you know, if we don't have the diagrams of the foam systems, we can come across issues. You know, with the equipment that we take, that allows us to be able to react to ensure that there are no delays. Obviously, these are critical assets. They need to be up and running as soon as possible. So we need to make sure that the downtime of each asset is as short as possible. We have a saying in our industry, it's good chemistry plus bad application equals bad chemistry. And what we mean by that is, you know, if the solution doesn't work, it's often blame on the chemistry, when that's not actually true. It's about the means of applying it and having the experience to be able to apply the chemistry, and that comes with experience. So I'll talk on the next couple of slides. I'll talk about the decontamination process and how that works. But what's important is to understand how we verify the success of decontamination. And we have a number of methods to be able to do that. One of the I guess more unique methods for us is the top-of-say surface testing. There's a lot of companies out there that may be testing the rinse water at the end of the decontamination, and testing the PFAS levels in that water, when actually that's not really telling you what the success of the decontamination is. Where you really want to understand is the PFAS levels that are left on the tank wall, because that's where your main risk will reside, because that's where the PFAS will rebound into your new fluorine-free foam and potentially make your new fluorine-free foam breach future legislations. Not only that, there'll be regret spent, because you'll have to replace that foam, and then you'll have to do an effective decontamination again. Effectively, what top-of-say does, we swab the tank wall pre-decon, and we swab it post-decon, and that's given a significant swab of 100 centimetre squared area, and we do opposite sides of the tank, and that allows us to determine the levels of PFAS on the tank wall pre and post. That will give us the data then to determine the success of the decontamination. We always do two methods of analysis. It's always good to have two different types of verification. Typically, we do AOF as well, which is absorbed organic fluoride. Now, that doesn't determine PFAS, it looks at total fluoride. And the way that we apply this analysis is during the decontamination cycle, we take 5 samples during the decontamination. And what we look for is the total fluoride that has been removed during that process. This has been really useful data for us, because it allows us to determine the length required to decontamination. There's been a lot of questions in the industry: at what point do you finish decontamination? There'll always be a level of PFAS. It's impossible to remove 100% of PFAS. You know, anyone that says that, it's not true. There'll always be a tiny element of it that what you're looking to do is remove the majority, you know, 98, 99% of that PFAS to ensure that your system remains compliant should the PFAS rebound. What AOF data does, it tells us that at what point during decon the total fluoride starts to plateau. And with the number of systems that we've done to date, we're able to determine by the size of a tank, the type of the tank, and even in some cases the type of foam that's in that tank, how long we need to decontaminate that asset to ensure that we're going to get the best results and ensure that that system remains compliant. We also undertake TOF analysis, and this will be looking at the entire PFAS compounds, if you'd like. As the restrictions become more enforced on PFAS, TOF may be a future analysis that we would need to do even more in the future. But at the moment, we're typically doing TOF+A surface and AOF analysis. And out of all the systems that we've done today, over 150 systems, we've had 100% compliance in terms of the success. So we'll talk a little bit about the decon process and how that is completed. So we can offer a turnkey solution from foam out to foam in. We very much work with what the customer would like and work with partners like Dr. Starmer, you know, where they may manage the foam out and the foam in. It's all what's best for the project and what's best for the schedule of the project. So typically, once we've got hold of an asset, we've done all of the pre-engineering work and all of the method statements and the RAMs have been signed off by the customer. We would drain and pump out the old foam. So we remove that, we store that. That is all contained in a closed system. It's all in a bonded area, so there's no risk of any leach of any foam that contains PFAS. That is stored away in IBCs and put aside for disposal with the decontamination waste. We then move to a water rinse, if you'd like. And then what the water rinse doing is we add the anti-foam, and as we do in the circulation, we circulate the water with anti-foam, and that could be either a liquid fill or a spray head methodology, the spray being preferred, to remove any foam residue from the systems, and that's from the tanks, from the pipe works, typically up to the propulsion system. What that does is when we ensure that when we start to add the chemical reagent and we start to add temperature and real flow to that to remove the PFAS, we're not going to see any foaming during the process. Prior to us moving to decon, that is when we will take our first surface sample. That's assuming that the tank is accessible for us to be able to get a surface sample. At no time do we physically enter the tank. Everything that we've done, there is no confined space required. We take the samples. We've developed like an extended arm, if you'd like, with a template that allows us to get an accurate sample of that tank. Then we move to the part which removes the PFAS, and that's the circulation of the chemical reagent PFAS scrub through the system. Now, typically, you know, if we're looking at an 8 to 10,000 litre tank, in terms to give you a time frame, you know, the water rinse, you know, that may take 8 hours, and then you move into the circulation. Now, that can take anything between 8 and 12 hours. Typically, we'll be looking at 12 hours of circulation of the chemistry at temperature. Now, you know, often with different tanks, you'll have different legs that we can direct the circulation via opening and closing valves. What we do is we connect we load into the tank, and then we load out typically post the proportion and unit, because that's the point where the most risk resides, because where your PFAS is going to sit is going to be where your foam has been residing, or your foam concentrate has been residing for a certain amount of time. And we will circulate that back to our circulation skid, where it's reheated again, the chemistry, and that will go on for approximately 8 to 12 hours. Where we're looking at much bigger systems, which won't be the case with these boats, you know, we can go up to 24 hours decontamination. You can see from the image at the right, that is typically what a circulation skid looks like. We don't take up a huge footprint. Typically, we're looking for an area of 10 by 10 meters. So once we've done the circulation, when we're doing the circulation, typically that's when we start to do the AOF sampling. So the guys on the ground, they would take 5 samples, and that will allow us to develop that second verification of analysis for us to be able to develop the report. Once we've completed the decontamination, we move to a final water rinse, and effectively that is just a water rinse to remove any of the chemical reagent. That waste will be approximately 99% water and a slight bit of chemical reagent. And then once we've completed that process, we then take another topper surface swab from the opposite side to where we took a swab previously. Now, with this type of analysis, this can take 2 to 3 weeks, which isn't ideal. These are emerging systems. You need to get them back in the field. And some customers, we present our data and we talk through our data, and they're pretty much confident with the success that we've had in previous projects that they are happy for us to load the new foam straight away. Other customers who are able to wait, they want to wait till they see the data. It all depends on the criticality of getting the asset back out on the water. So the data from analysis can take 2 to 3 weeks. That is completely managed by Tetra Tech. We have 2 accredited labs who we wrote the procedures with to be able to ensure that we get the right, they're doing the right sort of analysis. They're not just doing targeted analysis, which is also an area to consider. This isn't just about looking for the PFOA, PFAS. You've got to look for the precursors as well, because those are what can bioaccumulate and become into or convert into PFASs. So once we've got the reporting complete, that's developed by Tetra Tech, then the system is ready to be refilled with foam concentrate. I talked a little bit about circulation, so just to provide a basic diagram of that, if you'd like. If I just get my mouse on here, this is our circulation skid. This is where we dose our chemistry, if you'd like, and this is where the magic happens. All the temperature, everything's being circulated. We typically circulate down this line. Where we can, we use a 3D spray head, and the reason we do that is the main risk is the chemistry, is the PFAS on the tank wall. That's the area that we need to decontaminate, and effectively this spray head will sprays 360 degrees in each angle. We don't want to be filling the system because we're using more chemistry and we're producing more waste. We're looking for the best cost-effective solution for you. So we would typically spray the chemistry, and then that would recirculate, if you'd like, back into the skid, and that will go around in a circulation. We make sure that we have enough enough chemical reagent at the bottom to ensure that the lines are fully liquid filled, because obviously if you're using a spray head, you're not going to be able to spray head the lines, and we need to ensure that the lines are fully decontaminated as well. And then there'll be times where we may close this valve here, if you'd like, and we'd recirculate the chemistry in a different way. So wherever there's different lines connected, whether there's refill lines, we'll make sure that those are fully decontaminated as part of the process. There are other methods, liquid fill, and we have done some analysis on cold soak analysis as well. We've proven that that's effective, but in terms of the time that takes, it's quite significant. And unless you've not got a schedule you're working against, we wouldn't really recommend it. But if we do liquid fill it, then there are ways for us to reduce cost as well, particularly when we're looking at multiple assets together. But typically we would always look to do the 3D head circulation solution. I don't know if you can see this, if I can, right over there. So typically, these are some of the projects that we carried out over the last 12 months. To date, we've done over 150 systems. All have been with calculated rebound concentrations below the regulatory limit set for PFOA by the EU. If I look at 2 of these graphs here, so I talked about the AOF data earlier on, and this is typically what we would be looking for. So you have a timestamp, if you like, and there are a number of samples. And what this tells us is where typically, you know, after the third sample, we kind of reach peak fluoride. So we know that's got PFAS within it, you know, so we know, so if this is, so this is a 12-hour decon. So we know after 6 hours here, obviously this isn't in-field data, but we know once we've completed the decontamination, got the analytics back, you know, after 6 hours, you could go on for 24, 30 hours, even longer. Typically, you're not going to pull much more fluoride off. So that's a kind of that's kind of our secondary data. And then if we look at the pre and post decontamination data, so we've got the pre and post oxidization here. So, you know, we've got 49 million ppb of total PFASs and 18 million of PFOA. Once we've got the post-oxidization report, so this is the post-decon sample, you can see this has been significantly reduced by just over 99.8 and 99.91%. So what we do then is we look at this and we do an estimated rebound concentration. So we took 100 centimeters squared footprint, if you'd like, of, a sample area. And then we take that data, we extrapolate that data to say, hey, if that area was representative of the whole tank, what would the rebound concentrations of the whole tank be into your new foam? And then we compare that against the EU regulations, if you like, for PFOA. PFOS we don't typically see, but we fully expect to see some in the maritime sector, and then PFCAs as well. And we also do analysis on C19s and C9 to Z14s, which Thomas touched on before. But as you can see, we compare to the EU regulations, and we see that there is a significant reduction there in terms of the PFAS, PFOA that is remaining. So to summarize, we are experts in decon, and we're partnered with global experts in PFAS. We've got over 50 years collective experience in decontamination. Our procedures, we've got established procedures for all types of systems now, because we've done boats, we've done tanks, we've done vehicles, we've done jetty pipelines. So we've got every type of system that you could think of that we have decontaminated for PFAS. We're ISO certified 9014 and 45001 to carry out decontamination of these services. And we're operationally ready and environmentally focused organization. We're continually looking at how we can do this most cost effectively for our customers. We're in this business to work with our customers to find the right solution. We fully appreciate that a lot of customers haven't anticipated this expense to carry out this decontamination. So we work with yourselves to find the most cost effective solution. Thank you. Oh, Richard, you're on mute.
Thanks for that. Yes, Matt, thanks very much. And I think your comment at the end will ring a few bells within the industry, the process of having to not just be able to swap out into fluorine-free foams, but obviously to go through a decontamination process. Without further ado, I'm going to hand straight over to Jan Nappert, who comes from Dr. Stamer. He's the International Sales Director, who's going to talk us through the product development of the fluorine-free foam and its availability. Over to you, Jan.
Thank you. Right. Well, thank you very much, Thomas. Thank you very much, Matt. Very interesting presentations. And let me continue. So my name's Jan Nappert. I'm the International Sales Director for Dr. Stamer. I've been in the firefighting industry for 40 years and actually went to school with Richard 50 years ago. So we've known each other a long time, but we met up again actually at an exhibition last year after 40 years. So it's a small world. So I'd like to thank Richard for organising this seminar, webinar, and I hope that you're all enjoying it. So, firefighting foam in the superyacht industry, time for transition. We manufacture a range of marine-approved fluorine-free firefighting foam concentrates. After Thomas's presentation, where does that leave you, the end user? So,
sorry, Jan, is your screen supposed to be your slides supposed to be showing? Because it's reduced at the minute. I don't know why that
is it? Oh, is that better? Sorry.
Hang on a minute. Let me.
I'm not used to Zoom. Sorry.
No, neither am I.
Is that better?
Right, just bear with me. Let me see if I can make some adjustments here. Yeah, right, it's there, but I'm not sure what. There we go. Let's try that. Can everybody see that? Yeah, I should think so. Okay. Sorry, Jan, go ahead.
Okay, no, that's fine. Thank you. So where does that leave you? Where was your foam used on board? Are the fixed foam systems fed from central tank to engine room and machinery spaces? Are they local applicator foam stations on deck? Is the heli-deck system diffs, so deck integrated firefighting foam systems, or local applicator stations? So we start with the fixed systems fed from central tank to engine room and machinery spaces, typically low expansion foam for engine room and bilges under the deck gratings. We have a new Starmix Marine 3%. It's freeze protected to -20, and it's a direct replacement for AFFF 3%. It is a low viscosity product, so minimal pipework changes need to be done after you've decontaminated your foam tanks. It's approved to IMO 1312 for low expansion deck foam systems, IMO 670 inside air foam systems, and it's also tested to ICAO-B with seawater for helideck operations. It also carries MED Module B and D listings, so it is perfect for marine use. We also have high expansion inside air foam systems, which have been tested to IMO 670, but also has ICAO-B certification. So local applicator stations, which are available in 20 litre cans with tamper evident seals. We have the Starmix 3% freeze protected to -20. Then we have a 6% version, freeze protected to -15, and we have a 2% version as well. Now, IMO 1432 paragraph 711 states that for local applicator cans, 20 or 25 litre, which still have the original factory seal, you will have a 10-year life on the cans. And then you have to dispose of them in a environmentally responsible manner. Now, for helideck systems, you either have diffs if it's a big mega yacht, so deck integrated firefighting system, and can be used typically at 3%, or we have a 1% foam available for that. So as I said earlier, our Starmix Marine 3% is a direct replacement for AFFF because of its low viscosity, and also our Starmix IAF Marine 1% can also be used on ICAO-B helidecks. You can also use the local applicator stations for local intervention with the above foams, as long as you've had the necessary training, or I'd say your fire crews have had the necessary training. So, in general, foam concentrates we produce have a 5-year warranty, subject to correct storage to our instructions. Excuse me, what's happened there? So IMO 1312 requires annual foam testing after the 3rd anniversary of the foam if the foam is in system storage tanks. We can provide this testing for you through Maritime Aviation. As I mentioned earlier, IMO 1432 requires that for your local applicator cans, they have a 10-year life. It's not normally cost effective to test the cans because once you've broken the seals, you have to replace them. So we recommend annual foam testing to ensure efficacy when it's in system storage tanks after the 3rd anniversary. And we check the expansion ratio, the sedimentation, the pH, the specific gravity, the 25% drain time, and alcohol stability if it's an alcohol resistant foam. And as I said, Maritime Aviation can arrange all of this for you, to our BV accredited lab in Hamburg. So all our foams and services are available through Maritime Aviation. Now, I'd like to make a couple of comments on Thomas's presentation. With the impending IMO and ETCHA legislation, where there's a 36 months for civilian shipping, there is that is of course for European flagged vessels at this time. It is not for all internationally flagged vessels. So it is for European flagged vessels that this restriction will come into place first. Other vessels, we will wait and see what the European Union and IMO decide. So, thank you. Any questions?
Okay. So thank you, Jan, for that. I've picked up through other means a couple of questions. Some have probably been part answered, but I think that you know, both of them are quite valid. And just bear with me, I'm just trying to adjust my screen here. And I'll just call them out. So the first one is, why has the EU stroke IMO not been proactive and expedient with their decision making when globally fluorinated foams seem to be such a hazard? So Jan, do you want to take that one, or Thomas?
IMO has always been a very conservative organization, and have dragged their feet, especially on this PFOS image, because in Europe and most of the Western world, PFOS was banned in 2011. That's the C8 chemistry, and we had to transition away from that back then. But IMO haven't moved, but I believe they've had a lot of pressure from the EU to start moving, which is why we're seeing the restrictions currently being discussed on IMO, and will be gathering pace once the ETCHA legislation has finally been put in place, if I'm correct, Thomas.
Yes, you are. Like you said, like Jan just said, I think IMO is one of the organizations which are pretty, say, robust in their cause and not easy to deviate from the direction they've once chosen to drive. And the restrictions, the global restrictions on perfluorinated chemicals, yes, they are rooting back into the 2008, 2010-ish years when we see the first restrictions to come, but that was only Europe at the time, and from that it evolved quite explosively. So it really developed quite some momentum, and I think IMO will address that going forward. They have now taken a first shot in restricting PFOS, but they already say that I've said that in my presentation, they already say that be aware future restrictions on other fluorochemicals are following or might be following. So consider that when you move away from AFFF based on the C8 technology and you plan to move to C6 technology, for instance, that might be a regrettable investment. So also IMO already indicates that there is more to come.
And Thomas, do you think that there will be some serious monitoring going on within the industry for or ensuring that vessels have actually transitioned? You know, for instance, testing. We're obviously seeing restrictions on that now with fluorinated foams. Should the industry be concerned that litigation may follow if they don't comply?
Well, certainly, yes. These kind of environmental crimes, say, if you pollute, if you use a forbidden or a banned chemical, then that's an environmental crime, and that will certainly be enforced quite rigidly. Even more so is the insurance companies will. We see that already for other land-based installations, but that may travel also through seagoing units, that insurance companies are rejecting or refusing to accept insuring vessels if you're not meeting those requirements. So there's quite another lever to push ship owners towards following the legislation than just enforcement through different legislations. So the insurance companies could be a much bigger and more direct impact.
That's very interesting, because we are currently engaged with insurers for various reasons, mainly to look at improving safety and to ensure that they actually understand what they're underwriting. And we have been quite surprised actually at the reaction for them to have a desire to enhance their knowledge. So probably more to follow with that. The other question that's come in, I think Jan's already touched on, but it's the actual testing of finished foam. There seems to be discussion points that we have been confronted with shipyards and other organisations that ultrasound testing is sufficient once foam installation is taken place. Our understanding is that ultrasound is actually a flow test and not a finished foam test. Jan, would you like to elaborate?
Yes. The flow test tells you that you're going to get enough water through your system, and your proportioner will be given the right percentage. However, with fluorine-free products, it's the bubbles that do the work, and this is where we need to make sure that we achieve a expansion ratio of typically 5:1, and then a drain time of several minutes, because it's the bubbles that have got to do the protection and the firefighting. So without confirmation that you are making foam, making the bubbles, you may have an ineffective fire system. And with an ineffective fire system, you're going to lose your boat.
Yeah, good. Okay, well, everyone, thank you so much for attending the webinar. I hope you found it as useful as I and my colleagues certainly have. Very great thanks to Dr. Leonhard and Jan Napper and Matt Calverley. If you do have any questions that have come up post the webinar, then please email us at hello@maritimeaviation.com, and we will forward those questions on to the panelists and return a response. In the meantime, thanks everyone and have a great day.
Thank you.
Thank you, guys.